All right, we're going to begin 10.3 here with a quiz from 10.2. Obviously, you can use your notes, go back to that. So here we go, we have question 1 and 2. It says write an equation for the nth term here. So to figure this out, notice they give us the fifth term. So we can use that they gave us the fifth term and the common difference there, and plug it into our equation that we used yesterday to figure out the nth term. So let's do that. We need to first figure out, so a little bit of review on what the nth term equation is, right? So we have a sub n is equal to a sub 1, the first term, plus n minus 1 times the common difference. Notice that we need to have at least a1 and d to make sense of this equation. They did not give us a1, but they did give us d, so we're going to find a1. So to do that, I can say, all right, the fifth term is negative 12, right? So a sub n, I can treat a sub n as the fifth term, where I replaced n with 5. Okay, so I know that the fifth term is negative 12. I can say that that is equal to the first term plus n minus 1 times d, which is negative 4, right? And I can solve this thing out. By the way, I know what n is. N is 5, so I'm going to substitute that in on the next step, right? And I can solve this for a1. So I have negative 12 is equal to a sub 1 plus, this would be, if I plug this 5 in for n, it'll be 4 there, because it's 5 minus 1, times negative 4. Okay, so I end up with negative 12 is equal to a sub 1 minus 16. So if I add 16 to both sides, the first term is equal to 4. Okay, so now that I have that, I can make an equation for this. Okay, so the equation for this would be the nth term is equal to the first term, which is 4, plus n minus 1 times d, d being negative 4. Okay, I can simplify here, combine like terms. So a sub n is equal to 4, negative 4 times n is negative 4n, negative 4 times negative 1 is plus 4. Combining like terms, I get a sub n is equal to negative 4n plus 8. Okay, so there's my nth term equation for that guy. Then for number 2, find the sum of the arithmetic sequence. Okay, so if you review back to our sums formula from last time, what we did was we kind of took an average, right? So we took the first term, we added it to the last term, we divided by 2, and then we multiplied that by n, right? How many terms we had in the sequence. So in this case here, we need to know n. We already know the first term. Okay, so the sum formula was this. Take n, multiply it by the first term, which we know in this case is 4. Okay, add that to the last term, which is 200 in this case, divided by 2. All right, so we need to find n. Okay, so we know that a sub n is equal to a sub 1, which is 4, plus n minus 1 times d. Common difference here appears to be 4, right? So I can use this information now. I know that a sub n is 200, right? So the nth term in this case is 200, is equal to 4 plus n minus 1, sorry, not n minus 4, but n minus 1 times 4, right? So 200 then is equal to, I can solve this now for n. Okay, so this would be 4 plus 4n minus 4. These go away, and I get 4n is equal to 200. Therefore, n is equal to, if you take 200 and you divide that by 4, you get 50, right? So n is equal to 50. So I have the sum is equal to 50 times 200 plus 4 is 204 divided by 2 is 102. Okay, so if you multiply that out, 102 times 50, you end up with 5100. Okay, so those are your 2 answers on your quiz. Let's move into 10.3, geometric sequences and series. Okay, so yesterday we focused on the arithmetic sequences. Today we're going to focus on the algebra that is involved in the geometric. Okay, so first off, I'll give you the formula for this. The nth term of a geometric sequence is equal to the first term multiplied by the common ratio, which they call r, raised to the power of n minus 1. Okay? So in other words, if I am looking for the fifth term, if I'm looking for fifth term to figure this out in a sequence here, it would be a sub 5 is equal to the first term times the common ratio, all to the power of 5 minus 1, which is 4. Right? So take the common ratio to the fourth power, multiply it by my first term, and that is equal to the fifth term in the sequence. Okay, so that's kind of how that will work. So let's do some examples. For this one, we have Shira, I guess is her name, receives a joke in an email that asks her to forward it to 4 of her friends. I hate these things, by the way. She forwards it, and then each of her friends forwards it to 4 of their friends, and so on and so on and so on. If that pattern continues, how many people will receive the email on the 9th round of the forwarding? Okay, so we're going to use our formula we just learned. Okay, this is an example of a geometric sequence because each time we're multiplying the friends by 4. Right, so our common ratio is 4. So I like to identify things like, I like to identify my first term in the sequence, then I like to identify the common ratio, and then it's also important to identify what n is. In this case, we're looking for the 9th round, so n in this case will be 9. Right, so the common ratio here, each time we're multiplying by 4, and we begin with 4. Right, the first email comes to you and you have 4 people that you're forwarding it to. So we start with 4, and then we multiply by 4 each time after that. So let's just plug these things into our formula. So we have a sub n is equal to a sub 1 times r to the n minus 1. Okay, in this case, n is 9. So we're going to say a sub 9 is equal to a sub 1, which is 4, times the common ratio, which is 4, all to the 9 minus 1, right? So a sub 9 is equal to 4 times 4 to the 8th. Okay, so if you take 4 to the 8th power, you get 65,536. Multiply that by 4, and you get the 9th term. So the ninth term in this sequence would be 262,144. Okay, so there's example 1, just applying the formula that we just learned for a geometric sequence. Okay, so example 2 says write an equation for the nth term. So again, we're looking for this equation. A sub n is equal to the first term times the common ratio, all to the n minus 1. Okay, so we need these pieces. We know that a1 is equal to negative 0.25. We can find r. So r is just the value that we're multiplying each number by in order to get the next number, right? So we can figure that out by taking the second number in the sequence and dividing it by the first, or you can do that with any of these. Like you could take the third, if it's easier, and divide it by the second, right? So to find r, I could take the negative 16 and divide it by its previous term to figure out what I'm multiplying by each time, if that makes sense. So the answer to that is negative 8, and I can test that. If I take negative 0.25 multiplied by negative 8, I get 2. Multiply 2 by negative 8, I get negative 16. Multiply that by negative 8, I get 128, right? So r, I found, is equal to negative 8. I can plug in what I need to do now. So I plug in the a sub 1, I get negative 0.25. Plug in that r, which is negative 8. Raise that to the n minus 1. Since I don't know what n is, that's as far as I can simplify this. I am done. Okay, so that is the nth term equation. If I wanted to know, say, the 20th term, I would just simply plug a 20 in for n, and I would know what it is. Okay, so again, we came up with these formulas in Algebra 1. This is just kind of a review of it and using them, again, to keep them fresh, because they love to ask these kind of questions on patterns and stuff, and on college entrance exams and stuff like that. So, so here we go. 2b, we have a similar problem, but here they give us the third term, and they give us the common ratio. Okay, so again, I like to start by having this guy in mind. Okay, and then the parts that I know r, but I need to find a sub 1. So to find a sub 1, I can use the fact that I have a sub 3 to figure it out. I can say, okay, a sub 3 is equal to a sub 1 times the common ratio, which is 4, all to the, see, I replaced in with 3 here, so it would be 3 minus 1. Okay, since I know what a sub 3 is, like the third term, I know the third term is 16, so I can say 16 is equal to the first term multiplied by 4 to the second power. All right, so if I simplify that a little bit, I get 16 is equal to a1, first term, times 16. To get a1 by itself, I can divide both sides by 16, and I know now that a sub 1 is 1, or the first term in the sequence is 1. Okay, so now that I have that, I can use it and just plug in those two pieces and have my formula. So a sub n will be equal to the a sub 1, which is 1, all right, multiplied by r, which is 4, all to the n minus 1. Okay, so again, if I wanted to find the 20th term here, plug a 20 in, take 4 to the 19th power, and that would give me my 20th term. Okay, so that's example 2, you guys. I'm only going to teach you guys example, I think I'm going to teach you 1, 2, 3, and 4, and then kind of leave it at that, and we'll skip 5 and 6 for this lesson. So let's keep rolling here. The geometric means, the terms between two non-consecutive terms of a geometric sequence, the common ratio can be used to find the means. Okay, so yeah, this is just like the arithmetic means where I'm looking for the numbers in between, right? So they give me like the first term, maybe it's a 2, then they ask me what are the 4 terms in between 2 and, I don't know, we can make this up, 100, right? So what are the numbers that must go here if there are 4 numbers in between and you're multiplying by something each time? And so to figure that out, we need to figure out what r is. Okay, so we can use the information given to find what r is. So let's just do that with example 3. So in example 3, they tell us to find the 4 geometric means between 0.5 and 512. So let's just get a visual of that. We have 0.5, then we have 4 gaps in between, and then we have 512. So we're trying to find those missing pieces in the sequence. But in order to do that, we need to know what r is, right? Because in a geometric sequence, just to review, we're multiplying the previous term by some common number each time, right? So this constant thing is being multiplied every single time to get the next number. We got to find what r is. What is r? So to find that, I can just use my equation, like my formula for the geometric mean. So, sorry, for the geometric sequence. So we know that in this case, n, okay, because n is just the number of terms we're seeking here. We have 6 terms in this problem, right? So we start with the first one, we have 4 gaps in between, we end with the 6th. Okay, so we know that. We know that the 6th term is equal to 512. And we also know that the first term is equal to 0.5. Okay, so I have to find r. To find r, I can use the fact that I know a sub 6. So I can say, okay, well, a sub 6 is equal to my first term, which is 0.5, times r, all raised to the, since this is n is 6 here in this case, it'll be 6 minus 1. Okay, since I know a sub 6, the 6th term, I can replace it. So 512 is equal to 0.5 times r to the 5th power. Right, so now I can just divide both sides by 0.5. Okay, dividing by a half is the same as multiplying by 2, so I get 1024 is equal to r to the 5th. And then I take the 5th root of 1024, and when you do that, you get r is equal to 4. Okay, so you may need to look up on your individual calculators how to find the 5th root again. We did a lot of that earlier in the year, but hopefully you're still using the same calculator, you're able to figure that out. Now that I know that r is 4, I can just multiply each of my terms by 4. Okay, so if I take 0.5, multiply it by 4, I get 2. Multiply that by 4, I get 8. Multiply that by 4, I get 32. Multiply that by 4, I get 128. And if you multiply that by 4, you get 512. So that's how you find the numbers in between two numbers in a sequence that is geometric. All right. It's just using the same exact formula. Okay, lastly, I want to look at the sum of a geometric sequence. So there's two things here. Last time it wasn't too important that you guys learned both of the possibilities for the arithmetic sequence. This time it's important that you kind of keep both of these on hand, unless you want to refer back to your logarithms to solve for an exponential. So if you don't want to do that, I recommend just having these two things available. I don't know how important they would be to memorize, but having an understanding of how they work is probably most important. So let's use these guys. So this is, again, I think we know what a sub 1 means. First term minus the first term times the common ratio to the nth power, all over 1 minus that common ratio. Right, so we're going to use that where r cannot equal 1, because if that equals 1, we have 0 in the denominator, which is undefined, right? So r cannot equal 1 in this formula. Okay, so, and that would make sense because it would just be the same number over and over again, right? But anyway, so let's use that now for example 4. So again, what I would do if I have a sum, I would just start by writing this guy down, right? So the sum is equal to the first term minus the first term times the common ratio to the nth power, all over 1 minus the common ratio. Okay, so I happen to know all these pieces because they were given to us, right? So we have the sum equal to the first term, which is 2, minus that first term again, times the common ratio of 3, all to the 10th power. They gave us n. Okay, and then divide that by 1 minus r, which is 1 minus 3. Okay, so when you do this math, you get, and I did this out ahead of time, so I'm going to do this kind of quickly to save time. But yes, you would need to use a calculator to figure this out. So this would be, the sum of this, the nth term here would be 2 minus, actually I think I did this whole thing out, so forget that. Let's just do this. It'll be negative 118,096. So if you calculate that out, you'll get that. 1 minus 2 is negative 2. Okay, and then if you actually divide that out, you end up with 59,045. So hopefully you're able to do that on your calculators. Make sure that you take 3 to the 10th power first and then multiply by 2. Do not multiply 2 and 3 together first and then take that to the 10th power. That will not give you the right answer. Okay, so if you're running into the wrong answer, that could be why. On 4b, notice here they give us the nth term. Okay, so we're going to use the second equation here. If they give you a sub n, you're going to use this guy. So we'll take 2,000, we'll subtract the nth term, which is 125, multiplied by r, which is 1/2, and then divide that by 1 minus 1/2. Okay, so if you do a little bit of simplifying here, you end up with this guy turns into 1,937.5. Divided by 1 minus 1/2 is just 1/2. Okay, so when we divide that out, we get 3,875. Cool, guys. Hey, that's all I'm going to teach you for now. The sigma notation is just teaching you how to, like, kind of what we do with the arithmetic. So you kind of already are familiar with sigma notation. I'm not going to have you do that this time. So we're going to kind of skip through 5 and 6. And so your homework, I've modified a little bit. What I want you to do is, I want you to do, and I gave you a homework sheet so you guys can just refer to that, but I believe the problems on that were 17 through 45, and then I skipped a couple in there, so just refer to the homework sheet. And that's it, guys. Have a good day. We'll see you guys next time.